Problem 31 wants you to determine two pairs of coordinates for -8, -5 for between 0 and 360 degrees. Let me explain this problem a little more since it's not very well explained. This is in rectangular coordinates. They want you to write two additional polar coordinates for that rectangular coordinate between 0 and 360 degrees. We're actually going to write all four of them. Oh no, it's a 0 to 360, that's why. Alright, so let's first write this in polar coordinates. You go from rectangular to polar coordinates. R is the square root of x squared plus y squared. That's just the Pythagorean theorem. So it's the square root of -8 squared plus -5 squared. Notice that the negatives are in parentheses because when you square them, they're going to become positive. Now we're going to get the square root of 89. I'm actually going to leave that as a radical instead of changing it to a decimal because it'll look nicer. To find theta, theta is the inverse tangent of y over x if x is greater than 0. And it's the inverse tangent of y over x plus 180 if x is less than 0. Well, since x is less than 0, we're going to use this one. So the inverse tangent of -5 over -8 is going to be 32 degrees, approximately, plus 180 is about 212. So we're going to say that the polar coordinate is the square root of 89, comma, 212. This is in quadrant 3. So if you think about this on the coordinate plane, it's over here somewhere. We want to write one other angle for this, but it's got to be between 0 and 360. So the other thing that we can do is the radius could be negative if the angle is 180 degrees away from it. I actually already know what's 180 degrees away from it. It's 32. So the other ordered pair with the angle only between 0 and positive 360 could be at negative square root of 89, comma, 32 degrees. Number 32 wants us to find the equation of this polar equation in rectangular form. In rectangular form means that we want it to have x's and y's in it. So this is what I want you to notice. If I distribute the r, so I get r sine theta minus r cosine theta, r sine theta was y, and r cosine theta was x. So I'm not sure if we would write the equation like this, or it really is a linear equation, so we might write it like this. So I give you both versions. What if we want to go the other direction and write a rectangular equation in polar form? Well, x squared plus y squared was r squared, and y was r sine theta. So I want you to notice that I got rid of the x's and y's, I changed them to r's and thetas, but I want this equation to say r equals. So I'm going to start by subtracting the 6r sine theta, and then we're going to divide both sides by r. And I find out that r is -6 sine theta, and that's the polar equation. 34, we want to put the polar coordinates, we want to find the polar coordinates of this rectangular coordinate. I'm going to go about this a different way because I want you to think about where the ordered pair 5, 0 would be plotted in rectangular coordinates. 5, 0 would be here. Remember that the polar coordinate is plotted in the exact same location. So I want you to think about this in terms of r and theta. What angle is that? Well, the positive x-axis is 0 degrees. And what would the radius be? It would be 5. Now, if you really want to go about doing this way, you're going to end up finding out it's the exact same thing. You would find out that r is 5, and then the inverse tangent of 0 is going to be 0. but sometimes you can reason the problem out. For problem 35, we again want to change this rectangular equation into polar form. So what I did was I first went and replaced x and y. X is r cosine theta, y is r sine theta. Should say equals 3 over here. And then I squared both of those cosines and sine. So I got 3r squared cosine squared plus r squared sine squared equals 3. And then I factored out the r squared so that I had the 3 cosine squared plus sine squared in parentheses. And then I divided the other side by 3 cosine squared plus sine squared, except I had one additional thing I had to do, which was square root it so that it said r equals. If you're not sure if you converted an equation correctly, if you go back up here and you graph this in rectangular form, so you would graph the square root of 3 minus 3x squared in y1 equals, and y2 equals negative square root of 3 minus 3x squared. You should get the same picture on the graph that you get if you were to graph this polar equation. Number 36, we're going to rewrite r sine theta equals 4 into rectangular form. Well, this is y, and it's just the line y equals 4. In order to rewrite r equals sine theta, I'm going to multiply both sides of the equation by r, so I get r squared is equal to r sine theta. Because now I'm going to replace r squared with x squared plus y squared, and r sine theta is y. I can do the same thing if it has a number in front of it. I'm going to multiply both sides by r, and I get r squared is equal to 8r cosine theta. And I'm going to make that a theta. And I'm going to replace r squared with x squared plus y squared. And I'm going to replace the r cosine theta with x. The rest of the problems have to do with chapter 12 on sequences and series. Number 39 says form a sequence that has 2 arithmetic means between negative 12 and 21. That means there are 2 numbers between negative 12 and 21. We're going to use the equation a sub n is equal to a sub 1 plus n minus 1d to find out what the common difference is so that we can find the numbers in between. I know the last term, I know the first term, and I know how many terms there are. These cannot be added, so I'm going to start by subtracting 12 from both sides. So I get 9 is equal to 3d, so d must be 3. That means I'm adding 3 each time. So 12 plus 3 is 15, plus 3 is 18, plus 3 is 21. Number 40 wants us to find the sum of the first 11 terms of the sequence, 3 halves plus 1 half plus dot dot dot. Now, what I need to do is I need to determine if it's arithmetic or geometric. And it might help if I change these into fractions. This is 1.5, and then 1, and then 0.5. And you may be able to tell really quickly that the numbers are going down by a half each time. So this must be arithmetic. So the common difference is negative 0.5 because the values are going down. The formula for the sum is n over 2, a sub 1 plus a sub n. But here's the problem. I don't know what a sub n is. I know n is 11, but I don't know what the 11th term is. So you can either expand it out, which I'm fine with, or you can use this formula for finding the 11th term. The 11th term is going to be the first term plus the number of terms I'm going to minus 1 times the common difference. So the 11th term is going to be negative 3.5. Now I'm going to come back up here, and the sum is going to be 11 over 2 first term plus last term. And it turns out the sum is going to be negative 11. Number 41 wants us to find a sequence that has two geometric means between negative 2 and 54. The formula for the nth term of a geometric sequence is a sub 1 times r to the n minus 1. So again, the only thing I don't know is the common ratio. I don't know what I'm multiplying by. That's why I don't know the terms in between. So I'm going to start with the last term is equal to the first term times the common ratio to the, well, I know what n is, it's 4 minus 1. We're going to first divide by negative 2. So negative 27 is going to equal r to the third power. And then we're going to cube root both sides. And the cube root of negative 27 is negative 3. That means we're multiplying by negative 3 each time. So negative 2 times negative 3 is 6. Times negative 3 is negative 18. Times negative 3 is 54. In 42, we want to find the sum of the first 10 terms of this sequence. If I don't tell you if it's arithmetic or geometric, one of the ways you can tell really fast is I want you to notice that it's alternating signs. If it switches between positive and negative, it's geometric. So the sum of the first n terms in a geometric sequence is a sub 1 r to the n minus 1 over r minus 1. So first let's find the common ratio. The common ratio is the second term divided by the first term, which is negative 1.5. So we're multiplying by negative 1.5 each time. And I already know the first term is 1, and we're adding the first 10 terms. So the sum of the first 10 terms is 1 times negative 1.5 to the 10th power minus 1 over negative 1.5 minus 1. Notice the parentheses here. That's really important because on the test, people forgot that. And when they raised a negative to an even power, they got a negative instead of a positive. And I'm going to find out that it's about negative 22.666. I know it doesn't look like a very nice number. If you want to change it into a fraction by hitting math enter enter, my calculator spit out negative 11,605 over 512. Number 43, limits as n approaches infinity. We had a rule for this, and the rule was if the bigger exponent of the variable was the same in the numerator and denominator, then the limit was the sum, or was the ratio of the coefficients in front of those terms. However, if the larger exponent of the variable was in the denominator, the limit was 0. But if the largest exponent of the variable is in the numerator, then we said that the limit did not exist. Number 44, find the sum of the infinite geometric series, or state that the sum does not exist. The formula for the sum of an infinite geometric series was a sub 1 over 1 minus r. But there is only a sum if the absolute value of the ratio, so it doesn't matter if it's positive or negative, as long as that number is less than 1. The number has to be going down. It has to be converging towards 0 usually. So let's check r in A. R is the second term divided by the first term, which is 0.5. Well, that's clearly less than 1. So the sum must be the first term over 1 minus r, which is 20. How about in B? R is 1/4 over 1/8. 1/4 divided by 1/8 is 2. Oh, well, that's not less than 1. So if the common ratio isn't less than 1, no sum exists. 45. This was called summation notation. What summation notation was finding a bunch of terms and then adding them together. The way that it works is you start with the bottom number and that gets plugged in first. And then you take that term and add it to what you get when you plug in the next number. plus what you get when you plug in the next number, all the way up to plugging in 9. So this one's not a bad one to do longhand. This is called expanded form. So you would find each of these terms, and then you would add them all together. Most of you probably have on your calculator under the math menu, Math 0, Summation. Well, if you press that and type in the information that you need, in which case you'd find out the answer is 90. I don't care if you do it using expanded form or you use the summation function under Math 0. Now this only works if you have a start point and an end point, because in problem B it goes from 1 to infinity. Well, that you can't do. This is an infinite geometric sequence where we're going to have to figure out the first term and the common ratio. The first term is what you get when you plug in the first term. Well, what's 0.4 to the first power? 0.4. And the common ratio is usually what's inside the parentheses. So the common ratio is also 0.4. So the sum is 0.4 over 1 minus 0.4. And the answer is going to be either 0.6 repeating or 2/3. And the last problem. We talked about these things called binomial expansions. We had Pascal's triangle helped us do binomial expansions, where this was row 0, row 1, row 2, and so on. I want to find the 7th term in the expansion of 3c plus 2d to the 9th. Now, if you want to expand this all the way down to the 9th row, you can. I expanded it here to the 3rd row. The next one is 1, 4, 6, 4, 1, and then 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, 1, 1, 7, 21, 35, 35, 21, 7, and 1, 1, 8, 28, 56, 70, 56, 28, 8, and 1, and then the last one would be 1, 9, 36, 84, 126, 126. Let's see how many terms is that? 1, 2, 3, 4, 5, 6. Then the next one would be 84. So I didn't even finish it, but I can tell you the coefficient is 84. Remember that the exponents here go down for the first term. So 3c starts over here with the biggest exponent, and each term goes down by 1. So this would be 9, 8, 7, 6, 5, 4, 3. That means that 2d must be to the 6th power, because these two need to add up to 9. Well, this isn't the only way of doing it. Here's the other way of doing it. You can find the coefficient by doing a combination, rather than expanding out Pascal's triangle. The combination would be c, the power you're raising it to, comma, one term less than the term you're looking for. So if I'm looking for the 7th term, then this number is 6. And then you would have some combination of 3c and 2d. Well, this 2d would be 6 as well. This would be 3. And then in your calculator, to type this in, you type in 9, math, arrow over to PRB, number 3, which says NCR. So now this pops up on your screen, and then you press 6, and it'll tell you it's 84. So it's 84, 3c to the 3rd, 2d to the 6th. You have to multiply 84 times 3 to the 3rd times 2 to the 6th. And then the variables at the end will be c to the 3rd, d to the 6th, which is going to be 145,152 c to the 3rd, d to the 6th. And that is the end of the review videos for the Semester 2 final exam. The Semester 2 final exam has more than 46 questions on it. However, most of the information was covered in these review videos.